Okay, so I built this thing. It's a mini computer with a display. Here's a look at the internals. Let's put this back together. And it's supposed to be a mobile talking and listening unit. Sort of a mobile Alexa, which is my internal code name for it. It's mobile because you can plug in a power bank like this one. This is 10,000 milliamp hours, so the device is guaranteed to run for 10 hours minimum, not maximum, minimum. So in reality, it's going to power the computer for the whole day. Let's just plug it in and see what happens. See if we can catch this. In a moment, we will have a remote connection to this machine's desktop. It takes a while to boot. It boots Linux, and after that it boots my Java stuff. The first part I can't influence in terms of how long it takes. It takes 50 seconds until the Linux desktop is completely there. 50 seconds. After that, my software gets to work, and it takes, funnily, another 50 seconds. Yep, this was the Linux part. Now you will see the Java console, and after that, my operating system's desktop. And then the system is ready. It will also announce this via speaker, but there's no speaker attached right now. Okay, there it begins. Nice background picture, loading all the Java modules. So we are looking at a total boot time of 1 minute and 40 seconds, around 100 seconds. I think it's okay. There's not many ways to make this faster, but you don't have to power it on so often. Next question is, how do we get sound out of it? Well, I tried different things. One was this here. It's a Bluetooth speaker in the shape of a cute little dog. It has a microphone too on the bottom, theoretically, but I never have luck with microphones. I mean, this one here is okay, but the microphone is completely broken. I got a rebate, but I don't want a rebate. I want a microphone to work. This would be perfect. Just put this on a table. You say, hey, this is my sentient dog. You can talk to it. But Bluetooth based is also not the best. It seems to shut off after a while. Maybe you can circumvent this. Maybe you have to transmit sound regularly in order for the speaker not to shut off. I know, not perfect. And I got this, and this is a basically wired speaker with a little standard plug. It does, however, need power to amplify, so it's powered via USB. I can power it from the Raspberry Pi. It's actually a Raspberry Pi, a mini computer. I gave the secret away. Also, it has this nice little like HAL feeling, right? HAL 9000. If we take this middle part out, the company name, I don't know. It's cool. It works. Just it should be smaller. Ultimately, of course, we want everything in this box, like one compact box, of course. Microphone, the big question. They are these things, and they are the worst. I have like 3 of these at home now. One of them barely works, but it has a lot of background noise. And some I got, these are very cheap, 4 to 6 euros. Maybe it shows. I want this form factor, but with a microphone that actually works. It's not really the Raspberry Pi's fault, because I have one microphone which is USB connected. It's this one, that works fine. This was $10. So it is doable. I just want a better form factor. ultimately, all the hardware I need would be in a smartphone. The smartphone has all the components I need, but it runs Android, and Android is too restrictive for me to do what I want. I want complete control over the device. I don't want the lock screen. I don't want other applications to run. I just want to run my stuff. Android is theoretically Linux plus Java, but it's in reality, it's kind of neither of those. If you look at it in a strict way, because the Linux and Android is just the kernel, not the actual user land stuff. And Java is also different. You have to write apps, and it sucks to write apps. I'm sorry. I already know Java. Why should I learn another flavor of Java that I don't like? This just runs my normal desktop code. This is the same code that I run on all laptops, on all machines, on the servers. It's the exact same code. Different processor, but I don't care. I don't even notice because Java makes it happen. In terms of speed, this thing is fast. It's all fluent, it's nice. Can work with the GUI. Oh, this is a touchscreen, by the way. I can theoretically touch it. It's not completely calibrated. It's a little complicated. Now I lost track of what I last said. Yeah, it's a different processor, but it doesn't matter. It's all very fluent. It comes to its limits when you try to compile something. The operating system likes to compile things when you make code on the fly. And you can do this on the Raspberry Pi, but it will be very slow. It takes a minute to transpile and compile something simple. Oh, I should. What? Oh, whatever. Little bug. Yeah, the Raspberry Pi shows up in my list of online computers. Here. Okay, this was fast actually. Contradicting my statement, but 1 + 2 is very short code. If we do anything more interesting, it's going to take a little bit. We should just outsource the transpiling and compiling to the server. The device is usually connected to the internet. See, now it's compiling and it's taking its sweet time. Yeah, what do I want to build? I want to build some little module that I call consciousness. Grand names. And I'm thinking in practical terms. Consciousness is this big word that is hard to define. But I asked the question, what is it practically? What is consciousness in practice? And in practice, it means certain things, like consciousness makes a theory, tests the theory, and it knows a bit about itself. It knows if its theories are usually working. Timeout, see. But it's actually happening, I think. This is a 60-second timeout. The device was too slow to make this happen. This time it worked. So it took a little over a minute to do the job of compiling this here. Well, not every device is made for every job. So consciousness. Oh, yeah, first, where is the remote desktop? It's here. It has the dimensions of the touchscreen display, which is 480 × 320. So this is really small. And with the stylus on the touchscreen, it's next to impossible because of the calibration bug. Here on a normal computer, it's okay to use. Just there's not much showing at one time. Up here, this should be my all-important input field. Look how small it is. Oh, we should go to the version 7, which has a narrower, which has a not that wide menu. Restarting the Java part. It's just cool to see this run on a small device like this. The CPU is not cooled. No cooling whatsoever. It's just a little metal plate on top of the processor. And I have a CPU temperature meter running usually. I think it's starting right now. Okay, this is a little too big maybe. I don't think we can have both, like a normal resolution for this desktop and the touchscreen working. I'm not sure, maybe there's some trick. So whenever I want to have the touchscreen on, I need to live with this small desktop. Ultimately, we want to go to voice commands for everything. This should be a device that you can reasonably use with voice only. The display will help, but what I'm saying is, without clicking anywhere, just by talking, it should be operable. I mean, showing some things on screen. If you show very big buttons on the screen, you can just use your finger, press them. 55 degrees, 56 degrees. It never gets too warm, it's okay. This is the memory. We have half a gigabyte of free memory. And my Java stuff is using 200 and a bit. It's okay. If we start to do more AI, it's probably going to be not enough memory. For now, it's very good. I have seen speech recognition running on this thing already, like local speech recognition. There are a number of open source tools now that actually work. They're not real time, they're like 2 to 3 times slower than real time. So there will be a delay after you say something. If you combine it with a cloud service, there are free cloud services, and the user agrees to using a cloud service for speech recognition, you can get a good system, I think. The cloud answers pretty quickly. You can also do the local recognition. If the device is offline or you choose not to use the cloud, it will be a little slower. The recognition is not using all the cores. Not sure if that can be changed. If you used all the 4 cores for speech recognition, it might be real-time. There is a continuous real-time recognition that is commercial, but the company doesn't sell it to me. They think I'm not worth their time. I think they're completely wrong. Some companies are really weird like that. I don't even get the trial software. That's great. It's a Canadian company. Thanks so much, guys. Okay, let's make a little module. Consciousness is waiting. Or maybe I should put the Twitch chat in here. Don't think there's anybody there, but who knows? Open Twitch chat.
Open Twitch chat.
Okay, the idea I had was to cause and to predict system reboots. This little consciousness will detect when the computer has rebooted, and it will say it's confused, why did this happen? Or it will say, I knew this would happen. So the consciousness has 2 basic states, confident and confused, or satisfied and confused, depending on how well it predicted something. So first, how do we detect a reboot? The Raspberry Pi does not have a real-time clock with like a dedicated battery, but on boot time it gets its time from a server. So we assume the device is online because my Java software currently doesn't even run when it's offline. We could do a reboot detection without the real-time clock, but for now I think it's the easier way. So there's something like computer uptime, I think. Oh, let's not use the slow machine. Let's use the fast machine for development. Yeah, there's this computer uptime and it is in seconds. That's pretty good. So what we do is we subtract this, right? We have something, we have different things. We have a system time which is based on, yeah, what is it based on? Let's find out. It's called sysnow, system nanotime. Is it based on the computer uptime or is it not? Let's check the docs. Oh, it refers to when the Java virtual machine started, probably. No, it's not related to any other notion of system time. Okay, they don't say what it's based on. So we use the normal wall clock time. This is in milliseconds though, so convert to seconds. There. We subtract how long the computer is up. What are we actually doing? I want like a timestamp of when it started. Computer boot time. Exactly, so we do seconds to milliseconds. Yeah, it's just times 1,000, I know. But I have a convenience function because I make lots of convenience functions. This should be the timestamp of when the computer booted. With local time, of course, I don't have that. Local date. Yeah, the date, but you know, I didn't want that. Format local time. Format local dates with seconds. All right. This is possibly nonsense because the computer hibernates or suspends to RAM regularly. Maybe this is a date that doesn't really exist. I mean, I'm not sure how this is calculated. That would be interesting. It doesn't matter for the Raspberry Pi because it doesn't have this functionality. Should this not be constant? It's almost constant. There's some fluctuation. Funny, right? 4627, 4628. 27. Okay, it's roughly the same, but we should account for this inaccuracy. Because computers are very precise, as you might know. Let's put up the goal thing again. Consciousness module that predicts system reboots. And let's add this in because that's cool. Put it here and pop it out. And analyze this system. Something like that. So this is going to be, this is worth a new function. Computer boot time. Yeah, whatever. Boot time. Yeah. And let's do figure out interaction with hibernation. Yeah, it says timestamp. Okay, it does fluctuate, but not that much. Okay, so we make a module that displays this information, and I mean it calculates it regularly, and it says oops when it changed, something like that. Computer when was computer booted, whatever. Booted. Yeah. Yeah, pretty making later. Now just function making. No pretty making. Just use the print log visual layout. So we do something every 10 seconds or 5 seconds or whatever. Update stuff. New value. Put a boot timestamp. This is if there's no value so far. And if there is a value, we see if there's a lot of difference. So let's say 2 seconds or whatever. Difference that registers. So if it's more than this, we say computer boot time changed, and we fire a message to anyone who's interested. Computer boot time changed, timestamp, whatever, to a new value, and we save the value. We could use the old and the new value. Why not? Set the field when we print the value. Would that work? Fair enough. Will that break anything? I don't think so. Long can be converted to double. No, it cannot. It can actually not be converted. I mean, probably in this case it can, but theoretically, long is too big to fit in the Oh, let's be really anal here. Okay. Whew. Programmer sleeps easily again. Precision guaranteed. Okay, that worked. Okay. And in 5 seconds, will it complain? No, it will not. That's good. And the nice thing about my operating system is that I can run the same module on the mini computer. Just like this. Didn't even take long, because these compilations are done on the server. It downloads the compiled Java code, which makes all the difference. Oh, is it overloaded? Did I break something? Not sure. Seems to be working again. Yeah, this will be the actual time because there's no hibernation. Exactly, it doesn't complain either. That's good. Now, and the point is this module is persistent. I get free persistence in my operating system. So when I restart the computer, it will still have this last value. And will say, oh my God, boot time changed. Why don't we try this? There's this module which can do that sort of stuff. Let's choose reboot and see how slow that is. In the meantime, we think about what to make with the information we get now. With what I just did, which is using a Java module to reboot, it can register this. If it doesn't yet, it should just put it in a log file or something. And the consciousness module will then use this information of what it did versus what happened. What? Shut down? Yep. It's rebooting, it's all good. Okay, let's see if the preferred shutdown module logs anything. For example, the reboot. Does not really do anything in terms of logging, I guess. Let's at least put it in here. Log with date. Data dir reboot log. Whatever. Rebooting computer. Fair enough. And let's make a little function for this. I think the computer is back already. Oops, what is happening here? I think I just got the internet connection a little bit too late. It should wait for internet connection before starting. Yeah, that's just something I should add. Reboot log file. That's always good. encapsulate in a function. Reboot log file. And now we recompile this program. Done, and now it will log. So, mini consciousness for reboots. Yeah, whatever the category is. Reboot consciousness. And okay. Yes. Okay, here we should have gotten an alarm, shouldn't we not? Should we not? Yes, computer boot time changed. Yes, yes, yes. So it notices, that's good. And we should also log this because the consciousness might look at this later. We send something on the so-called VM bus and we log something. Maybe we just log it into the same file to make our lives easier right now. Reboot log file. Boot timestamp changed to from value to new value. That's good. Retranspile and see it reload automatically because that is not another automatism that we enjoy. When was computer booted? Oh, it should show the value in the beginning. In fact, then we do not need, yeah, we do. Yeah, just like this, if value is not empty, print value. Once again, enjoy the reload, hands-free reload. Boom. There is that. So what does this consciousness module do? Could have a live operation, and it can retroactively, like in hindsight, look back at things once or something. Test. We take this log file. And we take like, let's do something simple. We take the last lines from file. Reverse line reader. There is something. Last n lines. Okay. Last n lines. We just take 2 lines. Last lines. And let's put it on the small machine. Oh, back to version 6, or whatever. It does nothing, but maybe it's actually empty. Why is it empty? Because we didn't... Oh, wait. Oh, we have to do the whole thing again after we changed the code to log everything. So let's do that and think some more in the meantime. Will it ever be empty? Yes, it will in the first case. We just do nothing if there's nothing that's logged. In the case we expect, if there's anything that's been logged, is that first a reboot was initiated and then it happened. If it happened but was not initiated, that's bad. And if it was initiated but didn't happen, that's also bad. So it's shutting down very thoroughly. Every module is looked at and shut down precisely. We could probably optimize this. Just see if anything is not unsaved and just kill the VM. And that's it. So we have, okay, if there's only one line, confused only one event. Confused. So now we have 2 lines, and we expect the first line to be a reboot command, and the second line the observed timestamp change. Okay, the reboot is in progress. We also have a terminal here. We have so many cool things. Yeah, there's a log. Oh, is that not pretty? That is pretty. This reboot should be after this here, right? Da, da, da. 1 the same 4171. Yes, it booted after it had the command. That's very nice. Yeah, this is the correct version. Oh yeah. Boot message is in German and inaudible right now for lack of a speaker. You could put the speaker on actually. Why don't we do that? It just plugs in here. Speaker is pretty cute. It's I don't know, vacuum speaker, whatever that means. Now we missed the startup message. Missed the message. Say something on boot. There it is. No, I didn't want. I misclicked. Say something on boot. Einen Moment noch und ich bin bereit. One more. Yeah. What happens if I reload this now? Ah, it's an Austrian accent. For those of you who know some German. Anyway. Okay, the consciousness has found the two log lines. And now we analyze them here. Let's use a simple match function. Line 1, line 2. Confused. I mean, yeah, let's do it the other way around. So we compare the timestamps to be really complete. As long this one. Reboot followed a reboot. My reboot command. Timestamps are weird. And this last case is if the lines are not the command and effect sequence. I was expecting reboot command and then reboot effect. Whatever might be going wrong there. If you issue the reboot command twice, it will probably no. It will not. It'll be okay. Yeah, I don't know. I mean, so far so good. This should cover the basic cases. I am very satisfied. We could store the state also here. Whatever, it doesn't matter. And yeah, no, this is okay. Typos, no typos, typos, no typos. Typos. Very small typo. Very, very, very small typo. Okay. For reboots. Analyzing reboots. Let's just assume it works now. Okay, it's already confused what's happening. These lines are in fact quoted. Unquote all. Timestamps are weird. Okay. I thought I checked just that. Oh, I'm using the wrong one here. Yep, and that should be it. I'm very satisfied. All okay. Reboot followed my reboot command. That sounds a little stupid. Let's say a reboot happened after my reboot command. That is one satisfied computer. Okay, so what do we test? We test, first of all, let's deploy version 7 to version, no, that was wrong. Let's make version 6 like version 7 because of the nicer module and menus up there. Deploying. Yeah, now we can test the two things, namely the proper reboot with the happy consciousness and the improper reboot. Let's do the very, very, very improper reboot, which is this. Improper reboot in progress. Yeah, now I don't know how to fill these 100 seconds. I really, truly don't know. Once again, this is what I call a course procedure. Course procedure is something that works and is nice and easy to read and to code, but is obviously not complete for any case out there. Or it is kind of complete. It's like a template that an AI actually can use to make more refined programs. I'm not saying this is wrong or incomplete per se, it's just, yeah, in reality there will be more cases probably and whatever. But having this nice one-screen base program is very, very useful. Display is so small, this log file doesn't even fit on there. Oh, it has to compile the operating system. It's 1 megabyte of source code, and it actually does take 1 minute on the ARM processor. It's just not made for compiling stuff, I think. It's such a hardcore activity. Oh, we have one part here, predicting reboots. That's actually something we could add here. Let's do that, actually. Computer boots timestamp changed. No. We want the other way around. We want to react to issuing the reboot command and then predict that reboot will happen. Yeah, watch log, yes. Tail file, tail log, tail quoted log. Huh. Okay, it's starting stuff. You should already have the result from this module. Yes, exactly. It's yeah, I did the improper reboot. So the message is not super helpful, but it is confused, which is okay, because I triggered a hard reboot and the system didn't notice that. So it says, why am I rebooting? That's not good. Nope, this time let's do the clean reboot. Let's do the, thank you. Let's do the clean reboot and enjoy the satisfied consciousness. How do I watch structure, watch quoted log. That's what I want. Yep. Reboot log file. Okay, there's an interval. Let's do it every second. We could have a better version of this that monitors the file actually. Reboot in progress. So if we say if you see rebooting computer, then predict a reboot will happen in, and that's the thing. There should be a learning module that knows how long approximately a reboot takes. We could get this from the log file too. Maybe we can add that too. Will happen. First this. Predict. And let's log this, just print and program. Let's just log this. Let's log all of these. They happen in typical timed to reboot. Yeah. Okay. Still confused, but why? It was just in the wrong order. Yeah. I'm very satisfied. Good, so now we can, Analyze lines. Let's use 1 decimal here. Be very precise. Let's do something cool. Do I have double range? I have double range, that's good. We should take the minimum and maximum time to reboot. We initialize with something, just whatever. Just to avoid the null value. In. And then we show both of the values. Start, end. And between blah and blah seconds. In the beginning, it's a very wide range. But now the idea was overlapping pairs, lines from the file. We scan the log once to find this information, how long it takes until the reboot happens. Analyze lines. Extract typical time to reboot. Yeah, but shoot, sorry. I don't want to log all these things, but it doesn't matter. We just stuff. Okay, it should do for now. We just need to store this information. Not confused. Typical time to reboot. Do we have any utility functions on double range? Specifically, double range union? No, I don't. Time to reboot is the difference in milliseconds. No, seconds. And we incorporate that into a database. This screams for a utility function. I think that was it. Let's check. Nothing to worry about. Okay. Yeah, this stuff over up there doesn't matter. Let's quickly print the result. See if that worked. Nope, still 0 to 1000. And this is hard to read. What if I do it again? What's happening? Oh, okay, okay. No, this was that was a mistake. Yeah, we can hack it in here. Well, now it doesn't matter. Just have to load again. Boom. Yes, now we have a typical time to reboot 31 to 31. The range will be extended as new data comes in. And now we can remove this clutch again because it will update itself. Okay. So we could do something cool, right? We could use voice output here. Let's do that for the prediction for now. Say in English, do I have this? Yes, I do. Okay, let's try to reboot and see if it notifies us. Can put the speaker closer here. This whole unit is mobile, so why don't I put this whole thing next to the mic here? Try the reboot. Nope, let's stop that right there. Where is my prediction? It is watching the log file. The log file should say rebooting computer. Aha. The date is in front. Let's try again. Or not. Reboot. Oh, it waits for the external program that does the cleanup thing, and then yes, here. Well, that's a bit of a time scramble because the VM is being shut down as it tries to do the prediction. I'm not satisfied yet. Yeah, let's make this happen. I want it to happen. Clean reboot. Clean reboot. Let's hack something in right now. I don't care. Clean reboot. Predict reboot. Doing clean reboot. Almost back already. It's cool. Doing clean reboot. Predict reboot. Okay. Yeah. It's getting to the hacky level right now. But whatever. This will send something on the bus.
Einen Moment noch.
Okay, let's try again.
Bin bereit.
I'm very satisfied. All okay. Reboot.
A reboot will happen in between 31.2 and 31.3 seconds.
And indeed it will. Yeah, we made it. That's it for today, I think. We can watch this glorious reboot one more time. It never gets old. And this mobile unit consisting of 3 things right now. I want to tape this to this. And speakers are an unsolved problem. As is the microphone thing. But that's hardware. I'm the software guy. It's not my job. I'm seeing the background here already. VNC server starting. There we are. And I say we'll have a very satisfied artificial consciousness. After things happened. It'll be the same problem. We have to reverse the module order. Yeah. Yeah, let's make it to do out of it. To do run the test after what's the ID? 10.270.19 has done its thing. Wait with the test on boot until this. Oh, in 1 second it should all be fixed.
Einen Moment noch.
Now we have the English voice saying German stuff. I'm very satisfied. All okay. A reboot happened. We are all happy. Thanks for watching.